Solve for x in the following equation. 4x plus 1 over 2x minus 1 is equal to 2 plus 3 over x minus 3. Now the first thing we need to do is find the LCD, the lowest common denominator, of each of these terms so that we can multiply both sides by that value. So the LCD of the terms we're looking at, that's 2x minus 1 and x minus 3, is just multiplying them together, right? 2x minus 1 times x minus 3. That's going to be the LCD. So we want to multiply both sides of the equation by that value. So we have 4x plus 1 over 2x minus 1 is equal to 2 plus 3 over x minus 3. And we want to multiply both sides by 2x minus 1 times x minus 3. Now what I'm going to do first is I'm just going to multiply the LCD into each of these terms, and then I'm going to reduce in the next step. So I'm not going to reduce right now. I'm just going to multiply these in. So we got 2x minus 1 times x minus 3 times 4x plus 1. Oops. All over 2x minus 1 equal to 2 times 2x minus 1 times x minus 3 plus 3 times 2x minus 1 times x minus 3 over x minus 3. So now we're in a position where we can reduce, right? There's a 2x minus 1 we can factor out and cancel, and an x minus 3 over here. So what's left over is x minus 3 times 4x plus 1 is equal to 2 times 2x minus 1 times x minus 3 plus what's left over here, that's 3 times 2x minus 1. So now we have a lot of FOILing to do. So let's go and do that. Let's FOIL the left side. We got 4x squared plus x minus 12x minus 3. And then I'm going to FOIL these two terms first. And then I'm going to distribute that 2 in later. So this becomes 2 times 2x squared minus 6x minus x plus 3, and then distributing that 3 into that difference, I got 6x minus 3. So continuing to reduce on the next line, we got 4x squared minus 11x minus 3 is equal to, distributing this 2, we got, well, let's combine these first, and let me do this in this line. This becomes 2x squared minus 7x plus 3, right? So when we distribute that 2 in, this becomes 4x squared minus 14x plus 6 plus 6x minus 3. So now we combine like terms on each side. On the left side, there are no like terms, so we'll leave it as is for now. And then on the right side, 4x squared stays the same, but we got a negative 14x and a plus 6x, which gives us negative 8x, and then we have a positive 6 and a negative 3, which is just going to give us positive 3. So now we want to move everything over to one side. So I'm just going to do this in one shot. I'm going to subtract a 4x squared from each side. I'm going to add an 8x to each side, and I'm going to subtract a 3 to each side, right? Oh, and as it turns out, you end up getting something nice, and we're going to have to move some terms back. But notice that the 4x squareds give us 0 on both sides. Then we end up getting negative 11x plus 8x. That's negative 3x minus 6 is equal to, everything cancels out here, so we end up getting 0. And now, since there's only a linear term for x, there's only a one exponent for x, we can just solve for x like usual, right? So adding a 6 to each side, we get negative 3x is equal to positive 6. So x is equal to 6 over negative 3, which is negative 2. And thus this is our proposed solution. But since it's possible that this may be an extraneous solution, we should check it by plugging it into the original equation. So to check, we plug x is equal to negative 2 into our original equation, which I will rewrite right now. It's 4x plus 1 over 2x minus 1 is equal to 2 plus 3 over x minus 3. So we want to check to see if it's true. So doing that, we have 4 times negative 2 plus 1 over 2 times negative 2 minus 1, and we want to see if that's equal to 2 plus 3 over negative 2 minus 3. So on the left side, we get, on the numerator of that rational expression, we get negative 8 plus 1, which is negative 7, right? And then on the denominator, we get negative 4 minus 1, which is negative 5. And we want to check if that's equal to 2 plus 3 over negative 5. So simplifying both sides, we want to check if 7 fifths is equal to 2 minus 3 fifths. And how we combine the right side is that we find the lowest common denominator, which is 5, and we multiply 2 by 5 over 5 so that we can get a common denominator. So we have 7 over 5, and we want to check whether that's equal to 10 over 5 minus 3 over 5. And then finally, the last step, 7 fifths. Since we have a common denominator, we just combine the numerators, so 10 minus 3 is 7 fifths. So these check out, and thus our original, our proposed solution, x is equal to negative 2, actually works out.